elimination, and this is a very hard question, mostly because we have fractions. Okay, but as long as we're strong with fraction, it's actually really straightforward. So let's try to organize what we have. We have two equations, and they intersect at some point. We need to figure out what the point is. So let's number them. We have equation 1, and we have equation 2. My very first step would probably be to try to get rid of all the fractions. So the easiest way to get rid of fractions is to multiply the entire equation by some value. And that's actually a huge thing in elimination. In elimination, we do a lot of that. We multiply to make sure our coefficients in front of our variables are all the same. So that's a very common practice. So to get rid of fractions, we look for the denominators of both of them, and we want common multiples. Both of them happen to be 5. I should have made it harder. But both happen to be 5. So can you think of a common number that these both multiply into? 5, yeah, 5 is a really easy one. So we're going to multiply the entire first equation by 5. So that means every term. So here's a term, and this term. So when I go down here, the way I'm going to write this so that I know what I've done is I have equation 1 and I've multiplied it by 5. Okay, so that's how I convey my information to myself. So when I do that, I'm going to get 5 times 2 over 5, 2 over 5x, I guess I'll write it like that, minus 5 times 4 over 5y is equal to 5 times 1. And then we'll kind of work it out here. And again, it's still technically 1 times 5. Okay. What actually really happens here is these 5s cancel out, right? Great. And then this is what happens on this side here.
Times 5.
Great. So these became 1s. So now we're left with 2x minus 4y is equal to 5. Much nicer, way easier to look at. We can do the exact same thing here. Now, it might be easier for you to distribute everything first and then do that. What would you prefer to do?
Distribute.
Distribute first? Okay, so let's go and work on equation 2 now. Distribute everything, then get rid of the fraction. So, we're not multiplying equation 2, we're just going to distribute our information. So when we distribute, we take the value on the outside, and it has to be multiplied by both terms inside, and then same thing again over here. Now we can't quite see it because of the screen size here, but this will become 5 over 2y, okay? So 5 over 2y. This will become negative 5 over 2, okay? Over 2. Then, because this is technically, think of it like negative half, when I multiply in, this will become negative a half. Okay, so we get negative a half x, 1 half x, and then finally, when we multiply through, we get negative a half times 3. Do you know what that's going to end up being?
Negative 3 over 2.
Yes, that's right. Very good. Negative 3 over 2. So we get negative 3 over 2. Nothing happened on the right here. It's still equal to 10. We can get rid of our fractions now, but it might be nicer to collect like terms and organize all of our stuff. So what? Do you see any like terms first off?
Negative 5 over 2 and negative 3 over 2.
Great. Can we...
10.
And 10. You're right. Technically 10 is one also. So what do you want to do with them? You tell me what we'd like to do.
Do
you want to
them on the left side.
On the left side? On the right side? Okay, so let's move them all to the right. Okay, so we're left with still equation 2, 5 over 2y minus 1 half over 1 over 2x is equal to 10, and then becomes plus 5 over 2 plus 3 over 2, because they were both negative on this side, right? Okay, now in order to put these all together, I need them all to be the same denominator. So what should we do with 10 here? It's technically over
2.
Yeah, it's technically over 1. We need to multiply it by, like you said, 2. So it's going to become what?
20.
20 over 2. So let's just do that without writing an entire another step. It's a pretty simple idea. 20 over 2. So when we collect all these like terms, what are we going to end up with on the right side?
28 over 2.
28 over 2. And 28 over 2, is it? Yeah, it's exactly 14. You've read my mind. Perfect. So 14. We still need to write what we had on the left. 5 over 2, y minus 1 half x. Still equation 2. Let's get rid of the fractions. What should we do here?
Multiply everything by 2.
Yeah, let's do that. So I'm just going to kind of write this above, save us a little bit of room and time. Okay. What happens to this value here?
They cancel out.
Yeah, and we get
5y.
5y. Okay. What happens here?
Cancels out.
Yeah.
Becomes negative 1x.
Very good. Negative 1x. Or I'm just going to even write negative x, because we don't have to write that. And then over here?
28.
Yeah. Ooh. And that's technically equation 2 times 2. So, got two equations. Here's our other one. 2x minus 4y equals 5. I'm going to bring that down too. 2x minus 4y equals 5. We literally haven't even done anything with the elimination. All we've done is eliminated fractions. Now that we've eliminated fractions, in order to work with elimination, we want to get rid of actual variables. So we want the coefficients to add or subtract to to 0. We want them to eliminate. That's the concept here. So we usually try to order our things. You'll notice we have y as the first term, x is the first here. So let's reorder one of the equations. Is there any particular one you want to reorder?
No.
No? Okay, so you know what I'm going to do? I'm just going to take the first one. I'm going to switch the two spots. Become negative x. I already forgot. Is it plus 5y? Yes. Negative x plus 5y. Good. Okay. So now we're in order. We got our y's above each other, our x above each other, our constant terms above each other. We need the same coefficient. So again, you get to choose. Do you want to eliminate the y or do you want to eliminate the x values?
The x.
X values. And the x values would be way easier. Do you know why?
So you only need to multiply by 2.
Yeah, this one's 1. And 1 is really simple to make the same coefficient. Here we'd have to find a common multiple. Not the most difficult. 5 and 4. I know that 20 is a common multiple, so I can multiply this by 4, this by 5, and we can always get our 20. But let's do what you said. So now what we're doing is we still have this same first one. I'm just going to bring it down below so they're still above each other. But this time it's going to be equation 2 times 2, and then times 2 again. So it's really like we multiplied it by 4. That's just going to be my note, so I know what I've done here. So now we're going to get negative 2x plus 10y is equal to, and 2 times 28 is 50. Yeah, that's it. Very good. 56. Faster than me. Great. So, this is how we decide. Do we add or subtract? We need to eliminate these. So do we subtract the two values or do we add them? Yeah, when we add them, we'll end up with a 0. If we were to subtract them and we got a coefficient here, like what we've gotten 4, we know we've made a mistake because the whole idea is to get a 0 coefficient. So we're going to subtract the two equations. Oh, sorry, I lied. We're going to add the two equations. So that becomes 0x. You don't really have to write it in, but we did it for it. If we add these two together, what do we get?
6y.
Yeah, we get so positive 6y. And we add these two together, what do we get?
61.
61. The x is not important. So we get 6y equals 61. Y is equal to whatever 61 divided by 6 is. 10 point something tiny. 14 maybe or something like that. 10.14. Great. We can substitute the y in, or since we're practicing elimination, and this is a hard one, let's just go back up to this step here, and let's eliminate the y coefficients. I'm just going to do it on the right here. So we're practicing elimination twice. You don't have to. You can just plug the y in, but let's do it again. And this time, we're going to multiply the top equation. So we're going to multiply equation 2, which is already multiplied by 2. I'm going to multiply it by 4 because that's the opposite there. So it's like we've multiplied the original one by 8. So we'll get negative 8x times 4, so plus 20y. And 28 times 4, that's 56 doubled. 112, I think, is the answer. I hope it is. Okay? And then our other equation, which was already number 1 times 5, we're going to multiply it by 5 again, because that was the coefficient of the other. So it's like we've multiplied by actually 25. So 2 times 5 will give us 10, so we get 10x. Negative 4 times 5 will give us negative 20. All right. And 5 times 5 is 25. Yay. So we'll do this step a little quicker since we already talked about it. We know we're going to add because we have a positive and a negative. So let's add the two together. We're going to end up, these two become 2x. This becomes 0y, so I don't need to write it in. And we add these two, 137, I believe. So x is whatever 137 over 2 is. And those are just numbers. If you want a calculator, you can plug them in. But technically, the fraction is super accurate. This is technically the best answer. There's no rounding involved, okay? Mistake, right? This should be 2. Right? Nope, 4. 4, good. So, all the other stuff kind of stays the same. Here, we get a change. 10 plus negative 4 is, do you know? 10 and negative 4 is 6. Let's see.
Thank you.
Which means this is over 6. Okay. So we put in our calculator 137 over 6. 137 divided 6 equals 22.8. And I'm just going to put 61 divided 6 also in there. No. Yeah, divide 6. It's 10.16 and 22.83. And when we put the lines on here, that's exactly what we got. Good. We corrected our mistake. Yay.